We're going to do some examples of basic probabilities. Okay, again, with probability, you always do a fraction where the top is the number of possibilities that satisfy the event, and the bottom is the number of all possible outcomes. So in our first example, we're considering a family that's going to have 3 children. For the purposes of this problem, we're assuming that it's equally likely to each baby to be a boy or a girl. Okay. So we want to compute the probabilities of each of these outcomes. Okay. Now, the bottom 2 are actually the easiest. The probability that there are no girls is the probability that all 3 of them are boys. So the first one is a boy with probability 1/2. The second one is a boy with probability 1/2. And the third one is a boy with probability 1/2. We just are using multiplication principle here, since order very much did matter, first, second, and third boy. And we get a probability of 1/8 that they will have 3 boys and no girls. We can do something similar down here. If the 2 oldest are girls, notice we didn't say anything about the youngest. So the first child born is a girl, the second child born is a girl, and the third child, I don't actually care. It's not part of this. It could be a boy or a girl, which means I'm literally multiplying by a 1 here because I'm allowing all possibilities. So we get a probability of 1/4 that the 2 oldest are girls. Now, with at least 1 girl, okay, it's actually easiest to do a complement. So we're going to do this as 1 minus the probability of no girls. Because the complement of at least 1 being a girl is that none of them are girls. We already have the probability of no girls, so this will be 1 minus 1/8, which is 7/8. I could have gotten the same result if I added up all possibilities that satisfy this, namely 1 girl, 2 girls, or 3 girls. Okay. The problem is that if I say one of them is a girl, like I'm doing here, I didn't say which one of the 3 children is a girl, and those are different possibilities. So here, before I can do the probabilities of boy and girl, I have to pick of the 3 spots, youngest, middle, eldest, which one is the girl. Okay. And then I multiply by a probability 1/2 to get the first boy, 1/2 to get the second, 1/2 to get the girl. Okay. And I end up with a probability of 3/8. Again, we had to do this choose because there are actually 3 scenarios that satisfy this, the youngest being a girl, the middle being a girl, the eldest being a girl. And we can do those all at once by just saying we're picking which spot will be the girl. Now over here, there are 12 zodiac signs. For the purpose of this problem, we're going to assume that a child is equally likely to be born under any of the 12. Okay. And we're looking at a room full of 5 people. First, what is the probability that at least 2 of the people have the same zodiac sign? As you may have noticed when we did over here, the words at least make probability a little difficult. We tend to do complements for them. So I'm going to do 1 minus the probability that no people share a sign. Okay. Another way to say this is that they all have a unique zodiac sign. So it'll be 1 minus. In the bottom here, we're doing the probability, or the number of ways of assigning zodiac signs to all 5 people. Each one can have all 12, so it's 12 times 12 times 12 times 12 times 12, or 12 to the 5th for the number of people. In the top, none of them can share the first sign. So the first person has 12 choices for their zodiac sign. The next has 11 and 10 and so on. An easier way of doing that same calculation is just to use a permutation. Because order matters, it matters that each individual unique person has a different sign. And we aren't allowed repeats because we're assuming there are no repeats. So there are 12 zodiac signs, and I'm picking 5 of them without repeats. Okay. This gives me a probability of 89 over 144. Okay. Which means that I am more than 50% likely to have at least 2 of them share the same sign. Now here, it's a little bit different. I want to know the probability that at least 2 of them have Pisces as their sign. Okay. So, again, I'm going to use a complement. This is 1 minus at most 1 has Pisces. Notice I phrased the complement a little bit differently here because I'm being so specific about Pisces. What's really going to happen is that I have 2 scenarios that fulfill this at most 1 have Pisces. I could have 1 with Pisces, or, meaning I'm going to add the probabilities, I could have no Pisces. Okay, so it's going to be 1 minus. The denominator is not going to change, it's still that 12 to the 5th. To get 1 Pisces, okay, I have to choose which of the 5 people are going to be Pisces. 5 choose 1. Then that person's is chosen, and then the other ones all have 11 possibilities, anything but Pisces, so I get 11 to the 4th. For no Pisces, every single one of them has 11 possibilities, I get 11 to the 5th. Okay. This works out to be 911 for 15552, which is actually quite small. You may notice that another way to have gotten this number is to have taken this one and divided it by 12. This is the probability that at least 2 have the same sign. Because all the signs are equally likely, 1/12 of those should have Pisces as their same sign.